Give it with a find a function whose graph is a parabola with vertex 7, 8, and passes through 6, negative 9. And I got putting it in the standard form, but then from there I'm like, anything I put in screwed up my vertex. Oh, you broke it.
No, it became broken. I'll have to fix it later. So vertex 7, 8.
And then passes through the point 6, negative 9.
6, negative 9.
I'm on my third attempt, so if I do it, I'll mess it up.
So, what do you know parabola looks like functionally? I like it. I like it, but function-wise, what's the form of the function that
X squared.
And considering that they told me what the vertex is, why is that not the form I want to use?
Because I want to use standard form.
So I can actually put this in somewhere, right?
Yeah. And you just broke it.
No, I think you just fixed it.
It's broken already. Just calm down. No, it's got to go in there. Anyways, that's better. So I want to use this here. That doesn't happen.
So when I did it, I put in. It's easy to get the.
Are you guys kind of with me? I mean, I want to have a place to put 7, 8. Yeah. So I use this form. So now I can put 7
and 8
in there, because that's where the vertex would have come from. So far I know my function looks like this.
Yep.
And then it tell me goes, now what's the only thing I still really don't know here? What's the only real thing I don't know here?
Y.
A. Yeah. I know X and Y or whatever the hell I want to make it, right?
Yep.
But A is the thing I need to figure out. It's sort of like figuring out M. And how do I do that? How do you figure out B? How do you figure out B for, you plug the point in, right? So I know it goes through the point 6, negative 9. So where can I put 6?
X.
And not negative 9 goes there.
Yep. I did that and I kept getting the wrong answer.
So you get negative 9 equals...
Well, it's like 1. Yeah,
this is 1A plus 8, so A equals negative 17.
Yeah, and it definitely said you're wrong.
Too bad for you. Well, I mean, that's what it's got to be. That's the way it's given to me. So maybe shoot it through me over the email so I can take a look and see if it's a problem with WebAssign or what it is. Because that's what it should be.
Well, I'll do it. I'll just put that in, and if it comes up right, then maybe I was forgetting something.
Okay, all right. Good luck on that. But I like that kind of problem. I'll give you this kind of problem for sure, because it feels a lot like finding M and B for a line. You plug in what you know. You use the form that makes more sense. For lines, I could use y minus y1 if I wanted to, right? Yeah.
You just solve it and then...
What?
Yeah, I mean, negative 1 squared is 1, so that's where I got 1a.
Vertex, and then it passes through that.
Make the thingy.
Yes, okay. So I plug in everything I know, and then I figure out what I don't know.
So to write it, you'd write it with the negative 17 times.
Yeah, negative 17 times x minus 7 squared plus 8. That should be the form of the... Yeah, and it depends on what form they want you to give it in. If they say
It just says give a function.
Okay, so that would be a function.
And then the next question I had was, I got half of it right because it says use a calculator.
Okay.
And then, trying to let my internet do this thing.
Nice.
Okay.
All right, it says use a graphing calculator to make a quadratic equation is given 1 plus x minus the square root of 2 times x squared.
Oh, I see, okay. B.
And then, yeah, b. Absolutely.
So this is given to you, and what do they want you to do?
Well, it says use the graphing calculator to
find the max, and then you have to find yourself.
Yeah, find the max, and then it says do the exact and then compare the two.
Yeah, okay.
The
All
exact.
right. Graphic calculator should be able to do that, right?
Yeah, that
should be. Why does this guy have a max?
Because it's a negative.
Yeah, it's a negative thing in front of the x squared, so it's going to open down, right? Mm-hmm. Okay, we're all there. Cool. So on the graphic calculator, we all should be able to do that. Do the maximum function. It'll ask you left bound, right bound, guess, right? That kind of whole procedure. Mm-hmm. How do I find the maximum by hand? Maximum in this case is also known as the vertex, right? So if I find the vertex, how do I find the vertex? First step, x piece of the vertex is negative b over 2a. What's b? 1. What's a?
2 times the negative square root.
Negative root 2. Right, a is always in front of the x squared, b is always in front of the x. Okay, cool.
Now, on that one, you don't have to do the. Would you actually put the 2 in there with the negative root 2 then? So it'd be negative, or 1 over, yeah, that's what I meant. Would it be that?
That's the x piece.
And that's, you can't get anything further than that,
And
right?
if you want the max value, you figure out what the y piece is. I'm not sure how exactly they ask for it.
They just say, what is it?
What is
The
the
exact.
what is the exact maximum?
Yes.
All right, so that what is the output.
So that'd be the y.
Good. So you got to throw that in there.
Okay.
Yummy. Sorry. So 1 plus x plus minus radical 2 1 over 2 root 2 squared, and work it out. Don't give decimals. Just leave the radicals in there.
That's disgusting.
It's too bad. Of course, be careful. You can't cancel those out, right?
No.
Because the square root.
Yeah.
Cool. Okay. All right, not too bad. You can do that. I'm not going to do any more. That's plenty I did.
No, it's not.
Oh, wow.
Who just said, oh, wow?
I got it.
All right, you should tell me. So any other questions from homework?
Yeah, all of 3-2.
We haven't done 3-2 yet, so
You
that's.
said you started it.
I'll get there. Yeah, we started. Yeah.
Number 47.
47 in 3-1. Okay. If I ask you what's the domain of any polynomial function, what's the answer? All real numbers. Unless I restrict the domain, but if it's just a polynomial sitting there, a polynomial function, the domain is all real numbers. That's part of the definition of polynomial. If I tell you I'm working with polynomial, you know you can plug whatever the hell you want to in for x. It's not going to freak out. So a domain question about a quadratic function is easy. Any quadratic, the domain is going to be all real numbers. Now the range is going to deal with what? Who can tell me something about the range for a quadratic?
They're going to deal with the maximum.
Good, because it's going to come from negative infinity up to the max, or it's going to come from the min to infinity, right? So I have to first know, so in this problem, it was 47, right? So this one asks for the domain and the range. Coolness. So I know this is going to open up. So it's going to start at its minimum and go to infinity. So I already know the part of the range is going to be infinity. I just got to figure out what the hell that is. So all I got to do then, what's that going to be? It's the range. So what piece of the vertex is that going to be? The y piece, right? If I can figure out, I know it's going to look something like that maybe. It's going to have a minimum. I just got to figure out what that y piece is. I know it goes to infinity because it opens up. I just got to figure out what the y piece of the vertex is. So you do that. It's kind of weird that process works for a lot of different questions I could ask you. We just got to tease it out. That vertex is kind of like a starting point or an ending point for a parabola's range. Is that cool? Who asked that question? Does that get you started? And of course, you just do the negative b over 2a. That's the x piece. You throw it back in. There's your y piece. Cool.
Can you also put it in the standard form and find that?
Yeah, sure, of course. Yeah, whatever way you like better. So you can take the 2 out of the way. I mean, if I didn't have to, I probably wouldn't do it this way. But if you want to, you certainly, it's open. I always have people that like doing that, which really kind of is awesome in a way. But sometimes, that way is pretty damn quick. All right, is that cool for you guys? That was number 47 in 3-1. That gets you started on that one. Okay. Domain, of course, is always going to be negative infinity to infinity. If they haven't restricted it for any polynomial, it'll be that. So for quadratics, it'll be that. Cool. It's the strangest semester so far. Most of my classes are just like this. They're just like, are you with me? All right. Anything else from homework before we get into 3-2?
I have questions, but I don't have my book, so I don't know what to ask you.
Give me one of them.
All right.
What's the number?
64. He's probably an easy one.
Okay. This is one about a guy. Oh, it looks like a Chargers player. Oh boy. A ball is thrown across a playing field and then dropped. I mean, from a height of 5 feet above the ground. Blah blah blah. They give you the function that represents the flight path of the ball, right? Find the maximum height. So they give you. I'll admit that this is not a pretty looking thing. Poor little dude. They did the physics to this, and they really didn't clean it up. You see that? So this is built off of sound physics.
Plus 5.
Plus 5. Now it is. But you still do the same thing. How do I find the maximum height? That means I have to find the, and more specifically, the what of the vertex? The y piece. The height would be the output, would be the y piece. You guys kind of with me? If they said, at what time does it reach? Okay, that's the x piece. Right, because this is time versus height. So that you just have to find the vertex for part A. Get the y piece of the vertex. And then part B says, find the horizontal distance the ball has traveled when it hits the ground. What happens when it hits the ground?
Goes to 0.
The height is 0, so let that equal 0 and solve it. Again, it's a little gross, and I don't care. Right? The math is sound. Don't let the numbers freak you out. The numbers are a little gross. Oh well. Simplify this thing down, and it's happy. If it's not factorable, I can use quadratic formula. Right? But definitely simplify this down as much as you can before you start throwing it in places. Right? If you don't like fractions, I'm going to set this equal to 0 for part B so I can multiply by the denominator and kill it first thing. Make all my B and C a little bit bigger, but there's no fractions if you like that. Right? You got a lot of simplification you can do before you attack it. Okay. Maybe. God, if I could just read minds. I don't know. Okay, so let's get into 3-2. And we did get a little bit into 3-2. We talked about the end behavior of stuff. Let me show you a problem, and let me show you what will be the first step on a graphing problem. Will always be me asking you what's the end behavior. And let me show you the appropriate way to respond. Let's say I have this as a problem on a test somewhere. And I say, what's the end behavior? It's part A. Gotta be careful. Somebody just fallen into my trap. There it is. I like that. What do you look for to figure out the end behavior? Of course, end behavior means I'm letting x get bigger, really big, in either direction, right? Really big positive, really big negative. That's why it's called end behavior. What's it doing at the ends? In the middle, it can do all kinds of weird shit. At the outside, what piece of this is going to rule the day?
The highest power.
The highest power, and the highest power is the fourth degree. Now, normally, an even degree is going to look like, but what changes that here?
Negative.
It's negative, so it's going to be like that, right? Okay. So, when I ask you for end behavior, you say highest degree is like negative x to the fourth, or you can even just put down the whole freaking little term if you want to. You with me? Just point out the highest degree. and then give me a rough little sketch, like this. That's all I get. Don't fill it in, because I don't know what it's doing in the middle. This is all about the ends. That is how you tell me what the end behavior is. Why and what is it? If you just tell me what is it, I don't know if you're really figured it out for the right reason. You might have just graphed it and looked at it and said, hey, all right. How are we doing so far? Is that cool? So that's all we've learned yet from this section. There's a lot of stuff in this section. So here, you guys do this one. To find the end behavior for that. I would just stop you before you did. Nobody multiply that out. Really, please don't multiply that out. Good God. I'm not giving you this because I want to break. You guys do that. No. You should not have to multiply that out all the way. Now, hold on. Don't say anything out loud yet. Try to do it all the way out. Figure out why and then draw what? If you're not sure why or what, cheat off somebody next, or maybe talk to them. That might be better. Ask them what the hell's going on. Especially if it looks like they know what they're doing. What's different between this and this that made some of you go, oh shit, when I first wrote this down?
It's not multiplied
This is
out.
multiplied out, this isn't. But please, dear God, don't multiply this out. Because the next thing after end behavior I'm going to ask you is, what's the next important thing to get when you're trying to graph something?
Zero.
The zeros, the x-intercepts and the y-intercepts, right? So here I can see the x-intercepts. Why would I multiply back out? That's silly. I shouldn't have to. But if I did multiply this out, the highest degree would be
X to the fifth.
7. X times x is x squared, times x to the 5th is x to the 7th. Do you guys see that? If I multiplied this, into this, x to the 7th would be the highest degree that would come back out, right?
Is it a negative x to the 7th?
Good. I love it. So the degree would be a 7, but it would be a negative 4x to the 7th. So that's y. And then what would it look like then? Yeah, a normal cubish looks like that. So a negative cubish looks like that. Is that cool? You guys kind of with me? So that's the two ways you're going to see it written out, like it's not factored, which kind of sucks because it means you're going to have to factor it later. But then it's really easy to see which one's the highest degree. You're going to see it factored out. You got to be really careful about kind of thinking about what would it be if I put it back together. But please, dear God, don't waste time doing a fifth power of this. No need, please, God. What would the y-intercept of this be? Should be very little thinking required, because you make x 0, it doesn't matter what the hell else is going on, you get 0. Because of that one term there. And the x-intercepts? 0, 0. Yeah, 1, 0. So negative 6, 0. Sweet. Alright, good. Okay, cool. So, remind me something, because I'm teaching too many freaking classes this much. We talked a little bit about multiplicity and stuff like that, right? I think I've talked about it when we do the number line with the pluses and minuses.
Oh, yeah.
Remember? As though it was a second degree, it would stay the same sign on both sides. Alright, that is going to become huge right now. It's going to make a lot of our work quicker. So, for example, what is the multiplicity of each of the roots we got from this? Are they all even or odd? In this case, they all happen to be odd, right? Now watch, this is kind of cool. This is not good enough for a final answer, but here's negative 6, 0, right? Here's 1, 0, and here's 0, 0. So what it's going to do at each one, is it going to change sign or is it going to stay the same? Change. Be careful. What would a squared? An even power would turn, right? So that would mean it would turn at its root, it would turn. But these are all odd powers. It's going to go through this, through that, through this. Bam! Look at it. There you go. That's nowhere near good enough as a final answer, but that's a really nice rough sketch of what the hell this thing's going to do. Do you guys see that?
You said odd powers stay. No,
Odd powers go through. So it's going to go from, it was what on this side? The outputs are positive, and now on the other side of the root they are negative. Because it was an odd power for the 6. It was an odd power. Odd power things go through. Even power things turn. Right? So, let's try that. Let's add that into our mix here. Alright, so I want these things. I want you to tell me these things. I want you to tell me end behavior. You continue spell. I want you to tell me all the intercepts. And what it does at each intercept. So what's the end behavior? What's the highest degree? What would it make? Yeah, it would be x to the 6th, positive. So the end behavior would look like, there you go, cool.
Something the charters couldn't do.
Stop. Intercept. So the x-intercepts are sitting there staring you in the face.
0.
0.
1, 0.
0, 0. 1, 0. And y-intercept already know?
0, 0.
Yeah, 0, 0. Now the multiplicities. What's the multiplicity at 0? Yeah, it's the second degree, so it's going to turn. So put these answers up here. And the other two are odd degree, so they're going to go through. So there turns there or it goes through there. How are we doing so far? Now, if you don't like that, let me show you, let me remind you, you could do this whole process here. Nothing wrong with this. Where you've got your zeros. Remember this? Same exact idea, really. So if you really want to, so if you put a 2 in there, positive, 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 so it's positive up here. If you put a 1/2 in there, oh yeah, it's positive, negative, positive, so it's negative. If you put a -1 in there, it's positive, negative, positive.
So it's negative.
And if you put a negative 6 in there, positive, negative, negative, positive. I like it. So you guys remember that? You see how that comes back? Holy shit, there's a whole reason we learned that kind of thing. Now what did it do at negative 5? It was positive. Then watch, you can kind of, watch this. It goes from positive, it goes through negative 5 to negative. Then it's got to come back up to 0, but what's it do at 0? It turns. And right at 0, it's 0, and then it turns and stays negative. And then what's it do at 1?
It goes back up.
So it's going to look very roughly, really roughly like that. You guys? Kind of with me, okay. Somebody told me they were tired of me saying that, but I just can't stop. Sorry. If I say, are you with me? Just humor me. And if you're not with me, say so. Say something. Jeez. Okay, cool.
Physically working with you.
Yeah, thanks,
That'd be a
man.
different story.
I can count on you for that much. But of course, I mean a little bit more than that. Now let's go and try to graph this thing. I mean, not like that. That's kind of, huh? Oh. So of course, a really good starting point is my x-intercepts. So negative 5, 0, and 1. No, notice you're always going to plug in some other points. What is it? Something about this that I don't know that I really should know.
Where it turns.
No, like how big the
Good.
loops
How
are.
deep this gets, right?
Yeah.
How far down is that, and how far down is that? So what number? Obviously, here I want to plug in 1/2 to see what the output is. It's right in between. Now, I really want you to understand this. This is a rough sketch, because the true deepest point does not have to be exactly between these two, because this is not a parabola, is it? You with me? So the true deepest point could be anywhere in there. But my best guess is always in the middle. Or close to it. So what point could I plug in here?
Negative 2.5.
Or even better, let's just plug in negative 2. Just to make my life a little easier. I just want a rough idea how deep it goes. Right? The more perfect your final picture is, the more I worry that you just copied it out of a calculator. So I almost don't want your picture to be perfect. I want to see your work and how it translates to your visual. You with me? So if your visual is right, but your work is wrong, no. Right? If you do your work and you can't figure out why it's not looking like the calculator, I don't care. You draw your picture based on your work. You will get more points for that. I don't know if you guys really understand that. Because the big thing I want to realize here is how to get these things, and then what do they mean visually. You with me? So if you just copy it out of a calculator and get the right answer over there, it doesn't mean shit to me. You're not learning how to translate from what you did to what it looks like. Right? So if I plug in, so I want to plug in a few points. If I plug in 1/2, I get 1/4 times negative 1/8.
Oh dear, no.
Times 5.5, 11/2. So you get negative 11 over, what do you got, Jeff, 64? So it doesn't go very deep, right? You guys kind of with me? It does not go down very far. It's really very shallow. And then if I plug in negative 2. Do you notice how I haven't done a damn thing for the scale here? You didn't notice it?
Because you don't know yet.
Yeah, if I plug that in and it's 80, that's going to inform me what I want my scale to be. If I plug it in and it's 2, I'm going to make my scale much different than I would have, right? I want to get some idea of the outputs for these extreme areas that'll help me figure out my scale. You guys kind of, there it is again. All right. So when I plug in negative 2, I get 4 times negative 27 times 3.
Yeah.
So I get negative 324.
Yeah.
Yeah.
Yeah. See what I'm talking about?
Okay.
Okay. Damn straight. So this thing comes in and goes, wow. So what kind of scale do you think I want to use here then?
Tens.
Probably hundreds.
Yeah, maybe 50s. Too bad. Negative 50, negative 100, negative 150. No check. Alright, cool. That's pretty good. So up here we have 50, 100, 50. So at negative 2, it goes to negative 300 something. Right? Okay, how are we doing so far? Alright, and let's see. At 1/2, it went to negative 11/64.
So it's like right there.
And you can kind of overstate it a little bit because we're doing this by hand, so I can let you, kind of overstate it a little bit, make it possible to draw the damn thing. So now you just come in. The end behavior starts you off. So I know I'm going to come in from here, right? And I know I'm going to go, and you can even label this if you want to. Remember, it's turning at 0, 0. And the other two are through. Kind of with me? Mm-hmm. So as you come in, so you know you start up here. You can even plug negative 6 in if you want to know where you want to start, but this is just a rough sketch. So I come in like this, and then I turn around here somewhere, and then I back up, and then here I turn so I can get through there, and then I go through like that. Okay, cool. It actually looks
Really good.
not too bad. So if you graph it on the graphic calculator, you get something roughly like that, depending on how you set your scale. There we go. Not too bad, not too bad. So I'd rather you plug fewer points in, maybe at most 3. Here we just needed 2. Right? You could plug in negative 6, you could plug in 2 to see how high it gets, But those don't really matter. I just want the shape. In the middle it matters because it definitely would change the shape from, if I thought it was shallow, it would just be like that. But I know it's really freaking deep, so I know it's going to look more like that. Okay, cool. Good, you're good. So, all right. You guys do this one. And in our test or quiz, I will kind of do, part A, part B, part C. I'm not just going to graph. So you got to remember all these parts. Nice like that. For now.
Let's do a look at 3, 2, and 1. Homework-wise.
Are we turning this back in? Or
No.
is this first?
As messy as you want to be. You can work together if you want to.